These first three ask us, are they one-to-one? Okay, so you can either think about the graph of them. Okay, y equals x squared would look like this, right? And it would not pass the vertical line test. Or think about if I find f of 3 and f of negative 3. Okay, 3 squared is 9. F of negative 3 is also 9. Okay, so they both give me the same thing, so that's not. Okay, same idea here. You can either think about the graph. The graph would look something like this, not one-to-one. Or like if I find f of 2 and f of negative 2, both of them give me the same number, so therefore no. This one right here, absolute value looks like this, is a v-shaped, also no. Or if you find f of 2 and f of negative 2, once again gives you the same thing. Okay, so none of them are one-to-one functions. Okay, once again, we want to look at these and say if they're one-to-one or not. Okay, looking at this graph, no, it doesn't pass the horizontal line test, right? This one, yes. Okay, it only hits once. Okay, if you think about this is a parabola, right? It's a parabola opening down, and it went down 8 and to the left, right? So it'll be somewhere down here. Once again, no, it doesn't pass the horizontal line test. Okay, a cubed root function. Remember, cubed root goes something like this, and it moves and shifts and stuff like that, but it's going to pass the horizontal line test. And just y equal negative 7, just a line that goes across like this, right? It does not pass the horizontal line test. To verify that these are inverses, you have to find f of g of x and then g of f of x. Okay, so if I take this, plug it in there, it'd be 4 times x minus 3 over 4 plus 3. 4's cancel, it'd be x minus 3 plus 3, which is just x. And taking that, plugging it in there, so it'd be 4x plus 3 minus 3 over 4. Those cancel out, you have 4x over 4, which is x. So yes, they are inverses of each other. Okay, number 44 wants us to tell us what are the directions here, whether it's one-to-one. So if it is, find its inverse. So 44, yes, is one-to-one because the y's are different here. And then to find the inverse, so g inverse is going to equal, just switch x's and y's switch. So 12, 5, 22, 10, 32, 15, and 42, 20 would be the inverse. Okay, 57, to find the inverse, we switch the x and the y. So then solve for your y. Okay, so here's my inverse. That's my my y inverse is right here. Okay, so then it says to graph them both in the same. So x to the third plus 1 would be like this. Okay, this domain would be all real numbers, and this range would be all real numbers. Okay, and then the inverse, this one right here, cubed root of x. So the this way 1, and it would look something like that. And you can see the reflection across this line right here. Okay, and once again, the red one has a domain of all real numbers and a range that is also all real numbers. Okay, number 62, if you look at this graph, it would look like this, so it's not one-to-one. Therefore, there is no inverse. Fails the horizontal line test for the one-to-one. Okay, 63, this one will have an inverse, so if I switch them, so I have x times y plus 3 is equal to 2. Okay, I'm going to divide by the x and then subtract the 3. Okay, so this one right here, if I graph this, okay, so this one here, the original, we know that x can't be a negative 3, and we know it's a higher degree on the bottom, so it's right here and here, And we have this graph. So the domain of this graph would be x all numbers, but x cannot equal -3. And the range is all numbers, but y cannot equal 0. Okay, and then this one right here, we know it's all being shifted down 3. Okay, so we have x's here and here, and our graph would be here and here. Okay, and it did an okay job of getting that. But you can kind of see that reflection, like this blue part here would match this red, right? And this red part would match that. Okay, so you have the reflection idea. And for this part, the domain would be all numbers, but x cannot equal 0, right? Here is 0, which is the range there. And the range here should be the same as the domain, right? So it can't equal -3. So if this one is graphed, the graph would go here and here, but we're only for greater than 4, and that's where it actually starts here. It goes 4 and then it goes out like this. Okay, so it's that equation right there. And the domain for this one is from 4 through infinity. Actually including 4, right? So we're equal to. And the range, okay, starts from -infinity all the way up to 0. And it can equal 0 here. Okay, now let's find the inverse. So we gotta switch the x and the y. Okay, if I get rid of that, it'd be -x is equal to this. Okay, square both sides, just gives me x squared then. And add the 16 and take the square root. Okay. Okay, so what this one looks like is like this. But since we had it restricted, right, we only use this part of it here, we're not going to use the whole graph. So think about the reflection idea. So here's that y equal x. To get a reflection piece for this, it's going to be this part right here. Okay, so the inverse is this part right here, not this part here, because we had restricted the domain from 4 to infinity, right? Okay, so my range here should be from 4 to infinity. Okay, so we got that right there. So it's really not, yeah, so we have that. It's not the negative piece to it, it's just the positive piece to it. And our domain here for this one, domain are from -infinity to 0. And our range goes from 4 up through infinity. Notice it's just the opposite of that up there. Okay, these problems here only ask us, it tells us it's already 1-to-1, and it says just find the inverse. Okay, so all we got to do is switch and solve. Okay, so if I cross multiply here, I have 3xy is equal to 1 minus 2y. Okay, I'm going to get the y's on the same side. So 3xy plus 2y is equal to 1. I can now factor out the y. And I can divide by this now. Okay, so there is my f inverse of x. Same thing here, switch the x and the y. So this is x equals 4 minus y over 5y. So cross multiply, 5xy is equal to 4 minus y. Add the y over, factor the y out, solve for the y, divide by that factor. Okay, and that is the f inverse. Okay. Sorry, this should be an x, that should be a y. Okay, so I'd have cross multiply, 3x is equal to 3 minus 4y. 3x plus 4y is equal to 3. Well, I could have, yeah, I wouldn't have to do that, but anyway. 4y is equal to negative 3x plus 3. just solving for the y here. Okay, 78, switch it again. So x is equal to y over 1 minus 3y. Cross multiply, so we got x times this 1 minus 3y is equal to 1 times y. Okay, I'm going to bring this over to the other side. I'm going to factor out a y and divide by that factor. Okay, number 88 asks us to find f inverse of negative 3. So first of all, if we look at this graph here, I know that f, okay, I have the point, if my x is a negative 3, so I was wrong there with 88. 88 is f inverse of negative 2. So basically at the inverse, I'm looking at my original function. Okay, so if I think about the original point, the f function, so in my f function, my original point would have this as the y and then some x. Okay, so think about that. The inverse, you switch them around, right? So with the inverse, this is my x variable, but in my original function, it would be the y variable. So in the graph, where my y is a negative 2, has an x of 0. Okay, so in the original f function. So I know that this is going to equal 0. Okay, so the number 89, the f inverse of negative 3. So once again, in the original function, if this is my x variable, in the original function, in the f function, that's going to be the y variable. So where's my y, negative 3? Right here when my x is a negative 2. Okay, so equals negative 2. 91, 92, and 93 asks us, are they inverses? And we know they are inverses if they are reflections across this line y equal x. So yes, these are reflections. Yes, these are reflections. No, these are not reflections. These are, rotations around the origin, but not a reflection across the line y equal x. With 97, they ask, are these inverses of each other? So if I have the 0.16, the inverse of that would be the 0.61. 3.8, inverse would be 8.3, right? Okay, and they're all opposites, so 97 is yes. If you look at 98, 1.7, 7, negative 1, oh, no, that's not an inverse. So 97 is yes, 98 is no. You didn't actually have to do 98, but that's okay, we talked about it. Okay, number 99, you want to draw the inverse here. Remember, it's a reflection across y equal x. So that point would be reflected right there. Think about this point would be reflected right there. This is there. This point's over here. So it looks something like this. 102, you have to draw that inverse, which is the reflection. So that point right here. So this point would reflect over to be this point. This point would reflect over to be this point. Okay, so we'd have something like this. So you can see that reflection idea there for the inverse. Okay, 119. Okay, if we think about this graph here, we know it's going to be a parabola opening down and starts up here at +4, right? So it looks something like this. Okay, but it gives us this restriction. It says x is only greater than or equal to 0. So greater than or equal to 0 is here and above. So I'm looking at this part of the graph. Okay, so I'm not using this part over here. So for the inverse of that, if we think about the inverse, I have this here. I know the inverse is going to have to be reflected. Okay, so this point will be here. This point will be over here. This point over here. Okay, so I think about that reflection. And let's think about the inverse of this as well. So if we switch the x and the y, so bx minus 4 equals negative y squared. Get rid of the negative. Take the square root. Okay, so we have this graph right here. And which part of it is the actual inverse of this part, it's just the positive part, so not the negative part.